I clean my camera. Okay. Okay, listen here. In IGCSE O level, we are having a few units like kinematics, dynamics, work energy and power, thermal physics. Uh, Here, this next is electricity and magnetism and waves, and the last is nuclear physics. Here, very important thing is electricity and magnetism. In electricity and magnetism, almost in MCQ, like 15 questions out of 40. 15 questions will come, and then easy to score. You can solve if you know like few seven formulas. For example, in electricity, you can by heart some formulas, memorize some formula like Ohm's law. V is equal to IR. Voltage is equal to current into resistance, and Q is equal to IT. Charge is equal to current times multiplied by time, and E is equal to VQ. Energy is equal to voltage and charge, and P is equal to VI. Power is equal to VI, voltage into current, and E is equal to PT. Energy is equal to power into time. This is the main five formulas we have. So from this example now, cost problem. Uh, Cost problem means now you are consuming electrical energy, and then 2 units of electrical energy you consume, and each unit cost 2 cents. So what is the total amount that you have to pay, right? So in this case, you have to use E is equal to PT. Yeah. So don't forget to convert the power unit into kilowatts and time unit into hour, because 1 unit means 1 kilowatt hour, not in joules. So here you should note this very important point. Kilowatt power should be converted to kilowatts and time must be converted to hours, right? Okay. Then another important question, the formula is P is equal to VI. For example, what is the uh, current, the required current? For example, now you are using the electrical heater. The power rate of electrical heater will be given like 1500, and the voltage applied to the heater is 250 volt. So what is the minimum current required, or the current required for the electric heater? So in this case, we have to use P is equal to VI. And for the fuse rate, the same formula. So don't forget, if any device record how much current, if the power rate is given, P is equal to VI. Another one, fuse rate. What is the fuse rate? For example, now the refrigerator. The power rate of refrigerator is 2500, and the voltage supply 250. So if you divide, you will get 5 ampere is required for the refrigerator. So what is the fuse rate? Fuse rate will be always more than the calculated value. Suppose if your calculated value is 5 ampere, I told, right? Example, 5 ampere. Now means I think 2500 divided by 250 will be 10 amperes. Sorry, 10 amperes. So your fuse rate should be higher than 10 amperes. That means 13 amperes. So in the options in the MCQ, you can see 5 amperes, 10 amperes, 13 amperes, and 25 amperes. Now you see 5, which is less than 10 amperes. So you cannot use as a fuse, because smaller rate, the smaller fuse rate, what will happen? 10 ampere is flowing through the fuse, so it overheats and melt and break. So you cannot use your refrigerator. 8 ampere is also less than 10, and 10 ampere is exactly, it works if small fluctuation of current, the fuse melts and breaks and stop the current. So even your refrigerator can work more than 10 ampere, like up to 13 14 amperes, 15 amperes it will work. So what what is the right, the appropriate fuse rate is 13. 25, why can't we use 25? 25 is too large. It's large amount for the refrigerator. So what happens if large current passes through the refrigerator? Why it overheats? The refrigerator, the inside, the wires and everything is overheated and melts and catches fire. So it is hazardous. So you have to find out the right appropriate fuse rate. So what is the formula for the fuse rate? P is equal to VI. Okay, and then the basic formula, the mother formula for this electricity is V is equal to IR. Don't forget. If you know V is equal to IR and you know how to use this formula, you can solve almost all of the question in electricity. It's a very basic formula. V is equal to IR. You can by heart memorize very important relation. V is equal to IR, right? Voltage is equal to current into resistance. So sometime if you want to find the power rate, P is equal to VI, current will not be there. So what we have to do, you have to use V is equal to IR from Ohm's law. V is equal to IR is the Ohm's law formula. Using that formula, find the current and substitute value in the power rate. P is equal to VI. So you can play with the formulas here and there, and then you will get it. Okay. And then what else? If you have any doubt, and don't forget to learn about verify Ohm's law. Is the important theory question. Verify Ohm's law. That means first you have to talk about the experimental setup. There are few steps that you have to follow to score the full marks. First, you have to talk about the experimental setup like a battery, variable resistor, ammeter, voltmeter, and the metal wire which is connected. Yes, good, Osama. Fine. So here we are discussing about electricity, IGCSE, O level, the Cambridge. Okay, and then good to see you, Osama. How are you? I am good, Alhamdulillah. Okay, so now I am talking about the verify Ohm's law. How to verify Ohm's law? Okay, what is Ohm's law? Ohm's law says the voltage and current is directly proportional at a constant temperature. For example, if you want to find resistance, we need Ohm's law. We need Ohm's law. Now, how to find the resistance of the wire? Now, what we can do, take the power source, that is the battery, and you connect the metal wire, and in series you attach ammeter. When you attach an ammeter, you can measure the current passes through the metal wire, which we need to find the resistance. Okay, and then what is another factor that we need to find? We need to find the voltage across that we supply for the wire, right? So if we have the two information, we can find the resistance of the wire. What is the formula? V is equal to IR, R is equal to V over I, voltage divided by current, right? So the voltage, suppose you supply, that means it is up to you. You have to supply the voltage. You have to regulate the voltage by using variable resistor. So what is the function of variable resistor here? It will take some voltage and the rest of the voltage will be given to the metal wire which is connected in the circuit. So it is important. But if you don't have the variable resistor, the voltage is fixed. You cannot change the voltage. If you don't change the voltage, what is the drawback? You cannot have different values of voltages, because when you do the experiment, you have to follow some procedure. That one of the procedure is you have to repeat the experiment. How to repeat the experiment? By changing the voltage. How to change the voltage? By using variable resistor. You can increase and decrease the variable resistor. If you increase the variable resistor slowly, the variable resistor will take a few of the voltage from the battery and rest of the voltage will be given to the metal wire, that we need to find the resistance, right? So to change the voltage, we need to have a variable resistor, and the variable resistor can be regulated, and the voltage can be changed for the metal wire. Okay, now for example, you adjust the variable resistor and set 2 volt for the metal wire, and this time you check how much current is flowing in the circuit and record it. How can you see the current? You from the ammeter. From the ammeter, you can find the parallel connection. Voltmeter is connected in parallel, not in series, and the ammeter is connected in series. It's very important. Okay. Now one set of value. We got one set of value of voltage and current, and you record it in the table. So in the table you have 3 columns: one voltage, second the current, and third the resistance. So now we have 2 values, voltage and current, recorded already, and I have to repeat the experiment. How can you repeat the experiment? As I told you before, you have to adjust the variable resistor. Again you have to adjust the variable resistor and set 4 volt. Before it was 2 volt across the metal wire. Now you keep 4 volt, and again check the current. Now as you increase the voltage for the wire, what happens? The current increases, because the voltage means what? Energy supply. Energy supply. Can you tell the use of vernier caliper? Is the vernier caliper is the device to measure the thickness, length of a small device like a cylinder. You can example for IGCSE question. It is important question. The vernier caliper is coming under the measurement topic. The diameter of the metal pipe, or the diameter of the water pipe. How do you find? We have the instrument, 2 instruments. One is vernier caliper, another is the micrometer, screw gauge. So here the appropriate one is vernier caliper, because the screw gauge will go for millimeter, like the electrical wire is also cylindrical in shape. So you can use a micrometer for the electrical diameter of the electrical wire, and the water pipe, the size of water pipe, right? So you just think about the size. If you know the size, if you bring it in your mind, then think about the size, then you can easily identify the instrument. So the vernier caliper is the instrument to measure the diameter of the water pipe. Okay, and then micrometer is the instrument to find the diameter of electrical wire. Okay, hope you understand. Hussein Jaushan, hi. Hi, how are you? So we are discussing about IGCSE, because students are now going to attend the first term in Maldives, right? So they are asking me to give some information, so I came on live. So you can introduce, and then some of the new friends of yours. Hamna, hi. Hamna, how are you? I'm good. How are you? Okay. So is there any other question you can ask? The electricity, I was giving some information about electricity. Okay, after electricity, the very important topic is the thermal physics. In the thermal physics, we have like first is the thermal energy transfer and the thermometer, and then specific capacity, specific latent heat, and thermal expansion, and heat and temperature. These are all the topics, and these we have very few formulas in this. Yeah, thank you, Hussein Joshan and Osama. Through measuring the current, can some current be lost in the form of heat in the bulb? Yes, yes, we have. Yeah, very good question. Osama asked me a very good question. Students here, they ask this also. If there is a heat loss, whenever there is a current, there will be a heat loss in all the electrical device. If you touch after when it is turned on, if you touch the instrument, you can see, you feel some hotness, right? It is because it loses heat. So how do you find that heat energy lost? We have a formula that is you can note it down. E is equal to VIT, or P is equal to I square R, current square multiplied by resistance. So if you know the current, take the square of current and multiply by the resistance of the wire, and you will get the power loss. It is called power dissipation. It is very important question. I square R. Okay, I square R T. If it is energy loss, power loss, energy loss, both are same. Both are same. So energy loss, PT, right? PT. E is equal to PT. What is P? I square R multiply by T. Okay. So if they ask, Mikhail, how are you? Mikhail, yeah, very happy to see you all, students, my dear students. Okay, so I square RT. So I is the current, and take the square. Don't forget to take the square. Normally the students they use calculator to do the calculation, but they basically they forget to put the square. Yeah, very good. And then multiply by the resistance and multiply by the time. So you find the energy loss. If you want to find the power loss, just don't multiply the time. I square R. That is the formula. Okay, what I was telling about the thermal physics. In this thermal energy conduct, here you need to know about the very important thing is specific heat capacity and specific latent heat. Okay, what is the formula? Specific heat capacity, P is equal to, sorry, energy, the energy that E is equal to mc delta T, mass multiplied by specific heat capacity multiplied by temperature change. Another one is latent heat, E is equal to ml, mass multiplied by latent heat, right? So here don't forget to find the energy supplied using PT. That is, energy formula is, basic formula is energy is equal to power multiplied by time. So whatever the energy, even the electrical energy, we have PT, thermal energy PT, same formula. So there will be the power, there will be the time, so multiply. So if you know, then you will find the energy supplied, energy needed, energy is given to the device. For example, now you have the copper of 1 kilogram, copper block of 1 kilogram, and you supply, now you supply heat. How you supply the heat? You insert the heater. So first, before you insert the heater, check the rate of rate mentioned in the heater, and multiply by the time that you supply power. For example, you supply power for 10 minutes. So 10 times 60 is 600. 10 times 60 is 600 seconds. Multiplied by the power rate might be 100 watts. So 100 times 600 will be 60,000 joules that you supply heat energy for 1 kilogram of copper block. So specific heat capacity of copper block will be given like 400 joule per kilogram degree Celsius will be given, and you can find the temperature change. Okay, so here you should know the here very important concept. The thing is the mathematic equation, changing equations, right? Find the subject. For example, E is equal to mc delta T. If you want to find C, you have to bring the C as a subject and you keep it at the left side. So C is equal to energy over m delta theta, right? So what is energy? Sometime energy is given in the question paper, so well and good, you can use the same value. Suppose if the energy is not given, what will you do? Go for another formula, that is E is equal to PT, multiply power time, and you can substitute the value in the place of energy divided by the mass. And here very important thing, the mass sometime you have to use in grams, sometime in kilogram. It depends the C value given in the question. If the C value is given in kilogram, joule per kilogram degree Celsius, mass must be in kilogram. If the C value is given joule per gram degree Celsius, the mass must be in gram, my dear students. Don't forget this. Okay, unit conversion is very important, and then most of the students, they lose their mark unnecessarily with the unit. Even they know how to convert the units, but they are very careless. Yeah, and then who is the next? Azam. Hope you are doing well. Yes, of course, I'm doing well. Good. Thank you very much. Azam, how are you? Okay, then latent heat, and then here, very important, the latent heat, specific latent heat. What is specific latent heat? And then specific heat capacity. You supply heat, temperature increases. You release heat, temperature decreases. It is completely the topic specific capacity. You supply heat, temperature increase. You release heat, temperature decreases. Right? E is equal to mc delta theta. When will you use E is equal to ml? You supply heat, state changes. Example, solid to liquid, or liquid to gas, or gas to liquid, or liquid to solid. If state changes, you have to use latent heat formula is equal to ml. You should not use mc delta theta for any reason. Okay. So what is the clue? What is the keyword in the question? You can see 0 degrees Celsius, 100 degrees Celsius. That means in the boiling point 100 degrees Celsius, in the melting point 0 degrees Celsius. If it is given these degrees Celsius, then you should know it is a specific latent heat. Okay, and you should use E is equal to ml. Okay, here also that it is applicable. What? Joule per kilogram, joule per gram. You have to note the unit exactly, so that you can change the unit for the mass. So don't forget, students, here only you have two equations in this, and then one formula is there for the thermometer, three equations in this thermal physics. So most of thermal physics are the based on the concept based questions will come, but it is interesting and it is easy as well. You should know the concept, so read the textbook clearly. Okay, the complete physics, you are following the complete physics books. Please don't forget to read the textbook. It is the one of the very important what asset for physics. Very important thing, the complete physics. Yes, the Stephen Popple book. Hey, Salah, how are you? Yeah, good. I'm good. How are you? Okay. So what else? What's another important thing here? Heat energy transfer. So that is conduction, convection, and radiation. In conduction in the solid, convection in the liquid and gas, through liquid and gas, and another is through vacuum, and all solid, liquid, and gas radiations will be there. Okay, and here is very easy. Here the keywords are very important for conduction. What is a very important keyword here? The When the heat is supplied to the solid, molecules or the atom, they vibrate and disturb the neighboring molecules, and the heat transfer from hot to cold. That's all. I'm telling again, listen carefully. Molecules or the atom vibrates and disturb the neighboring molecules. Heat transfer from hot to cold. That's all for the conduction. What is for the convection? When the liquid or the gas is heated, it expands, becoming less dense and rises. And more dense of liquid or gas sinks. More dense means what? Cold more dense sinks and forms convection current. And for the radiation, it is the form of electromagnetic waves can travel through the vacuum from hot to cold. It is in the form of electromagnetic waves. So here in the radiations, we have surface, like two surface. What are the two surface? Black and white. And the black is the good absorber and the good emitter, and the white is the good reflector. That's all the good reflectors are poor absorber and emitter, and all the good absorbers are good emitter but a poor reflector. That is important. Here we have a experiment also for this, how to prove the black surface is the good emitter or good absorber. So that reef reef hello sir. Hi Reef. I could not identify, sorry. Can you just say more about you, please? Reef. Yeah. So conduction, convection, radiation. This is the heat energy. Then thermal physics, thermal expansion. In the thermal expansion, Brass is very important. It's a good expand. It expands more than invar. There are two. It is a bimetal strip. Yeah, important question. It bends. You have seen. It's a repeated question. It bends downwards and bends upwards, right? Uh, if brass is on the top and it expands more than invar, so how it bends? Upward or downward? It bends downwards. So you can see the length of the curvature on the top curvature will be more than the inner curvature. So outer curvature expands more, which means it has more length than the inward, means the brass expands more. Thermal expansion. Okay. Next here is heat and temperature, and then thermometer. The thermometer, you need to know how to calibrate the thermometer. You place the thermometer in the pure melting ice and mark the lower fixed point and place the thermometer above the boiling water. Shavi, hi bro, how are you bro? And place the thermometer above the boiling water and fix the upper fixed point, mark the upper fixed point and divide the two fixed point equally by 100 divisions. Each division is 1 degree Celsius, right? This is how we calibrate the thermometer. Okay, so here the important things I told you: the specific latent heat, and then specific capacity equations, and experiment. How to find the specific capacity of aluminum block, and for the water, how to find the specific latent heat of melting ice and then boiling water. That you have to learn clearly. And then I mentioned the E is equal to PT. Here also we are using E is equal to PT. That is PT is equal to MC delta T, or E is equal to MC delta T. Delta theta or delta T, same change in temperature, T2 minus T1. Yes, fine, Azam. I'm fine. How are you? How are you, Shavi? E is equal to MC square. Hey, Shavi. You finished your O level, okay? Yeah, good, Azam. Alhamdulillah. Good to see you all again. Good. Muskuli bebege, kafage, darige, muni, kafa. Gentlemen, yeah. Muskuli bebe. Mm. Mm. Shavi, how is how is things? How is everything is going on? It's good, everything. Koba bittu. Don't tell anything. Okay. Okay. So here just started how this live works, and then inshallah in future I will come and then I'll help you. I am with you all anytime. You can ask your doubts and post your comments, so then I can explain like this anytime. Anytime I will be with you, inshallah. Okay, so thank you very much for watching and then supporting me, and then please forward my link for your friends, those who are doing O level. Okay, thank you so much. Yeah, yes, sure. Okay, bye my dear students and my friends. Thank you very much.